Welcome to all. Today's class is most important master question for moment of inertia. Part 1. Actually, I already finished recording. Then at that time I thought this master question, see, you can see something here. This all will come little later. Little later it will come. Consists of many parts. So I first thought I can upload everything in one single class. But by the time I finished centroidal axis, IXX and IYY, it nearly took an hour. Then I decided, if I upload all the further part, it may take another 1.5 hours, total 2.5 hours, too lengthy. So I decided to upload in parts. So now most important, real, critical, ultimate, remember, master question for moment of inertia, part 1. Part 1 is furthermore important because moment of inertia about centroidal axis, IXX, IYY, we are calculating. This all I will explain further, it will be explained. So since it is moment of inertia about centroidal axis, this is a real important question. So first, now I will give the question for you. Already recording over. What I am doing is this I am adding in the beginning for the today's class. Anyway, right now for you, I want to give information that I am uploading in 2 parts. This is part 1. Okay, we'll continue. Welcome. From today, we are going to start calculation of moment of inertia. That is serious part. What I will do is, first class today, I will solve master question. No number here. Next class, I will put question 1, question 2, etc. This is a master question. So, master question. Class means I will tell you, this is master question for moment of inertia. This is not numbered. Here, we will consider each and everything required, complete concept, and repeatedly go through again and again and again, etc., again, I don't know how many times, till you get perfection. Now, I will tell you one thing. Once you correctly understand this question, it will take time. This will be a long class. See, I am recording in parts. That's why it will delay. Once you understand this question and get complete control, in future, you will have no difficulty for moment of inertia. It will be so easy that within no time, you can get the moment of inertia. And there are a lot of concepts are there. All the concepts will be covered in this class. So, this question is the ultimate master question. So, do not skip any part. Sometimes people will tell this is easier, I will understand. No, don't do that way. Spare some time. Go through each and everything and understand. Okay, start. Question is for the given either lamina or area or cross section. Anyway, this shapes here. Or you can tell angle section, cross section, or sometimes people call this as angle section. Angle section. Or some people even call L section. Okay. They will tell L angle. No, don't call L angle. L section. Find moment of inertia, see, about centroidal axis. Remember, this is plural. Plural, axis, not axis, centroidal axis, and also about, see, once first you find about centroidal axis, and then about, see, BC, AB, AF, CD, ED, EF, and then also one outside axis here, 1, 1, 2, 2, 3, 3, and 4, 4. very lengthy class. Okay, then also find radius of gyration about all the above axes. That is very simple. Why? Once you get moment of inertia, root of I divided by area will give radius of gyration. So complete. And simultaneously make a note. I will explain that polar moment of inertia also in between. Okay, now all dimensions are in millimeter. So see, this is 211 is 90 mm below. Actually 4 axes which are outside, 90 mm below. 22 is 70 mm to left side. And then 33 is 80 mm above this edge. And 44 is 50 mm to right side. This is the question. So what I will do is, now somewhere here I will sketch this question and write what all required here. That I am not going to remove till the end of the class. It will be there permanently till the end, most probably, I don't know. In case there is space requirement there, I may remove it. But I will try to maintain that sketch. See, that this is words given. I will remove everything now and write here, so that as much as possible I will maintain it till the end of the class. Okay, I will write first. So I noted down here given question. See, 130, 170, full number, 20, 16. That 4 axes I have marked here. Then all in millimeter. Required moment of inertia about centroidal axis. Class, I will tell you. Centroidal axis means you make a note there. Structural engineering, that is the most important. Others all only for understanding, academic or other purpose. Because sometime in examination they may ask you any random axis, but structural engineering we always want moment of inertia about centroidal axis, that is IXX, IYY, I will explain later. And also I about BC, I about AB, I about AF, I about CD means this way, I about ED, I about EF, then 1, 1, 2, 2, 3, 3, 4, 4, and also radius of gyration about all these axes. Okay. Class, dictated. I forgot one thing. You can make a note here. This example is nothing but the same question, Engineering Mechanics class 144, part 3, lecture 3, example 1 of locating centroid. Therefore, locating centroid, I should not explain much. Only this question I will write something. Next time onwards, you should do it. And also, I have decided this question first. Now, right now, we want what? See, right now we want moment of inertia about centroidal axis. First, I will do that one. See the question here, moment of inertia about centroidal axis. Then, so many other axes are there. So, I have not yet decided. Maybe I will finish centroidal axis today and upload as part 1. Otherwise, class will become very lengthy. And part 2 will be for remaining axes. I have not decided still. You can make out, when I upload, you can make out. You can see there part 1 or part 2 like that. Okay. Otherwise, single class. Okay, start. This all over now. See, class, dictated. Divide the lamina or given area into 2 parts. Say 1 and 2. You should write it here. I am dictating 1 and 2. See, divide like this. Then, see, 130, 130, 20, 20, 16, 16. This total is 170. From 170, see, this total is 170. Subtract 20, this rectangle, this vertical dimension will become 150. Not given, see, 150 is calculated. It is not given. I round off. It is calculated. Okay, 150 over. Now, after this, you go here. Don't come here. Come here. Actually, right here. Here I want this space. That's why I wrote here. Don't see here. Right here. First moment of inertia, I, about centroidal axis. Axis, not axis. See, centroidal axis. It is plural, not singular. Make a note here. Axis. Plural. Class. Centroidal axis means axis. Any centroidal axis is axis passing through centroid of the entire cross section or entire area. So there are infinite are there. See, suppose imagine you make all this note. This is the black color I will go for. See, this is the, you should make all this note. This is the angle. Imagine for this angle section, this is centroid, G. Through centroid, you can draw infinite axis. See here. You can draw a horizontal axis, vertical axis. Usually you will call this as XX, YY. And then, see, you can draw axis this way, axis this way, axis this way. So many axes are there. Among all of them, XXYY is the most important. But actually for angle, when you consider in column, XXYY, even though they are centroidal axis, they are not principal axis. There you require some UU and VV that we will discuss in the steel structures, not now. Right now we won't worry about it. So make a note. So centroidal axis means, you don't know what happened here. Okay. Centroidal axis means any axis, all the axis which will pass through centroid. But the most important is horizontal and vertical. So make a note here. In the class, you write there, in the class understood, now onwards it's understood. If they ask horizontal centroidal axis, it is, this write this way. So in the class, right here, in the class, in future, if they mention in the question about centroidal axis means understood, it is, see, centroid G here, horizontal axis XX, see, and vertical axis YY. This is red color, okay, YY. These are the centroidal axis. So that is horizontal axis say XX and vertical axis say YY passing through centroid G for the entire area. This is not centroid for this part 1 and part 2. Centroid G for the entire area. First we have to locate centroid. So what you have to do? First you write all these, right? First we have to locate centroid. Okay, start. Okay, I write here first. See, therefore first we have to locate centroid, that is capital G, for entire area. Now class. First of all, I should not talk. It is already over. See, location of centroid, so many questions, more than 60-70 questions are over. In the beginning, see, part 3, example 3, part 3, that is actually part 3 and example 3, not example 3, part 3 and lecture, I forgot the lecture number, part 3 and lecture number, I forgot that lecture number, I forgot out there, some, okay, you check there, part 3 lecture number, I'll check and write, part 3 I wrote correctly I think, if I wrote anything wrong I'll correct it now, part 3 lecture number, some etc. something, lecture number 3 also, both are same, fortunately. Example 1, this question, centroid location is very, very systematically explained. Therefore, right now I should tell simply x bar equal to y bar equal to. No, I will not do that way because this is the master question. We cannot do that way. Therefore, right here, even though it is already over earlier, briefly, right here, briefly, he will explain. He means me. He will explain. But you should write systematically. Remember, you should not write briefly, systematically. See. Divide into two parts. See here. 16 150. Oh, this dimension I forgot right here. Okay, right here, no problem. See, forgot to enter here. One thing I want to enter. Okay. 130. 130 and 20. Part 1, part 2, our choice. Then, mark centroid of each see, this is not centroid for the entire area. Small g is centroid. You should write all these. Now onwards, centroid will come many times. Sometimes centroid for the part, that is small g. Centroid for the entire area is capital G. Remember, make a note now. Whenever we consider centroid for part, it is small g. And whenever you consider centroid for entire area, it is capital G. And area wise, if you do part, area is small a and I is IG. Whereas when you consider entire area is capital A and it is I means IG. See, IG. This all you have to make a note. Okay, make all this note. Then start. Consider now to reference axis required. I will take origin here. Somebody will tell, sir, that point is already called B. That you call later, don't worry. See, this B, C, C, D, E, F, A, B, all will come later. Right now, we have 170, 130, 20, 16 divided here. Moment of inertia about centroidal axis. Therefore, A, B, C, D are not required. So, I will take the point O here, origin. See, from origin, I will take X this way and Y this way. Okay, maybe small y I write, understand? Small y, X and Y this way. Now, consider reference axis, okay, OX, small x. OX and OY, this is not capital X, see, this XX, this X and this Y is not your red color XX. Red color XX will come later. This is only reference. OX, OY, OX and OY, okay. OX. Let X bar, see, red color, be horizontal distance of centroid G. See, I told you, horizontal distance is from vertical axis, OY. See, from OY, X bar, from OX, Y bar. Okay, start. We have formula. We have, you already know it, X bar equal to, your formula is known for you. See, this is actually broken now, part by part. A1x1 plus A2x2 divided by total area. Total area is equal to A1 plus A2. A1 plus A2. And same way, Y bar equal to A1y1 plus A2y2 divided by total area. Total area is once again A1 plus A2. A1 plus A2. Okay, now do one thing. Start. Therefore, see, write a note here. Only two parts are there. Table is not required. Table required if you got multiple parts, 3, 4, 5 parts. Simple one, table not required, side by side calculation. So, X bar, see, your X bar is to which side? Right side. This I told you. Right side from where? See, that was equally important. From X bar is from OY axis. From OY equal to, start. Area of the first figure, 16 into 150. 16 into 150 is the area A1 into X1. Distance of its centroid G1 from here. Simply, if it is 16, rectangle, 16 by 2. This is all known for you, 16 by 2. Plus A2, 130 into 20. 30 into 20. No, I think there will be a space problem there. I don't know how much space is there. Okay, to save the time. Plus, okay, I write here. 130 into 20, part by part, into distance of its centroid from OY axis. This is 130 means 130 by 2 into 130 by 2 divided by, see this x bar equal to, okay, divided by sum of the two area 16 into 150 first area plus 130 into 20. You will get x bar in millimeter. Okay, I'll calculate now. Even I don't remember what is the answer. I have to go and check it, but instead of going and checking there, I'll calculate. 16 into 150 into 8 plus 130 into 20 into 65 divided by 16 into 150 plus 130 into 20. 30. Oh, this question is set so that round number. Usually when you consider angle, you will get, see, I got 37.64 exact answer. Otherwise you will get 37.18431194 like that. Oh, I remember. This question is because that class we made multiple options. I set the question so that your x bar, y bar are defined numbers. 37.64. This will confirm answer is correct. 37.64 millimeter. 64 millimeter. And now next. Y bar, which is to the upward direction. See, upward. I'll write here to save the space. Okay. And see, y bar in upward direction this way. From where? From y bar from OX equal start. A1 16 into 150. 16 into 150 is the area A1 into distance of its centroid from OX axis is, see, this rectangle starts here. So from here it is 20 plus another 150 by 2. 150 by 2. A1 Y1 plus A2. 130 by 20 second area. 130 by 20 second area into its centroid from OX is 20 by 2. First of all, I should not explain this one. Divided by, actually I should put equal here to understand correctly, equal here. Divided by 16 into 150 plus 130 into 20. Now some statements are there. Get the y bar in millimeter. This also should come round number because question is set that way. 16 into 150 into 75, oh not 75, sorry, 16 into 150 into 20 plus 75 plus 130 into 20 into 10 divided by 50.8 millimeter. Round number, okay. 50.8 millimeter. Okay, now some statement I am giving, dictating. See, this I will remove now. Some statement I am giving, very important. What all I tell you should write. Suppose, see, I write, this I will remove now. X bar, y bar are there. Okay, now. After this calculation, some statement. Okay. Okay, this also okay. I can, this number is required. Right here. Suppose your question is only to locate centroid. Then what you do is, you should not write cut sketch. You see, then right here. Suppose your question is only to see, suppose the question is only to locate centroid G for the entire area, then what you do is you write the original sketch here without breaking. See, this way. Without breaking, write it. Okay, this way. And mark that OX, OY if you want. O, see, this is X, this is Y, and here enter the values. Mark G. X bar from OY, we got 37.64. See, this is 130. So 37.64 will come somewhere here. See, this is your X bar calculated. X bar 37.64 from OY, and from bottom edge OX, we got Y bar 50.8. See here. This is from here. You got Y bar 50.8. Then, suppose somebody will ask, what is this distance? What you do? From total 170, you write always boundary dimensions if you want. Write boundary dimension. Other things are not required. This is 130. Okay. Write full boundary dimensions 130. If this is 50.8, from there it is 170 minus 50.8 is 119.2 millimeter. From there, see, 119.2 calculated value, and if somebody wants from this side, it is 130 total. 130 minus 37.64 is 92.36. 92.36 from here. Out of scale, this is calculated value. All dimensions are in millimeter. You write, therefore, you should write here. See statement, therefore, centroid G for the entire area is as shown, intersection of these two G. You write this sketch and over. Question is over. Okay, this all you write. Now write, but you write all these. See, I'll remove this one now. Once you write this one, first question you write everything. This I will not explain each and every time now. Only I told you in my class, people who are serious, they will go through everything and understand. Those who are not serious, why should I bother about them? Those who are not hardworking, those who have no patience to go through everything and they want shortcut, better go to some other place where people teach much better than me, if they find. Okay, now right here, but in this question and also in all the questions coming up next now onwards, I will not waste my time. In this question and also in all the questions coming up now, multiple, more than 100 questions will be there. You will be asked to find moment of inertia about centroidal axis. Therefore, that centroid G, you have to locate in this sketch only. Because when you find moment of inertia, right here, when you find moment of inertia, again you have to do part by part. Therefore, see, now don't write boundary because we want all these dimensions. So, therefore, what you do is in future, when moment of inertia is required, I required about XX and YY, you go back to the sketch. But today you write once again. Next time go back, but next time also I will tell you. Today you write once again. Today again write, and come here, start. See, from here, this way, X bar, how much it is? 37, I forgot, that number is rubbed out. Now I forgot it. What is this one? I forgot it. 150, 16 into 8 plus 130 into 20 into 65. 150 into 16 into 8 plus 130 into 20 into 65. 37.64. What you do is come here. See, draw this. Today you draw this sketch once again. Next time not required here. 37.64. See, 16 here. Little this side. See. Somewhat to scale. And see, this I will remove now. These are all unwanted now. See, now, these are all unwanted. Actually, what you have to do is you leave some space here next time. See, what you do is see here. Okay. 1 minute. 37.64, I remember. See, from here it is, see, continue. This is your x bar equal to 37.64. Then if you want from here, mark it here. Always better to mark from other side. From total, how much total? Total is, I will mark here. The total width here is, how much total width? 130. Mark in between. This 150, I want shift here. For some reason, I want shift that 150 here. See, there's a reason for it. Okay. 150, because first question should be crystal clear. All dimensions are in millimeter, and this is 130 minus 37.64 is 92.36. This is 92.36. Red color I am making. Red color corresponds to what? 90, forgot. See? 92.36. 1 minute. This is your x bar equal to 37.64. From here it will be 90. 92.36, and this total dimension is how much? 130. I want the dimension here. The total is 130. Okay, somewhere here. See, up to here. 130. Enter here. 130. You enter here only. I don't know why it's happening today. 130. And vertically 50.8. See, this is 20. Little more. Around somewhere here. See. Okay. The 2 is obstructing me. I will tell the 2, you go that side. Go that side. Don't disturb me. Okay, 2 here. See, this is your one more axis. From here to here is your y bar. Again, space problem. I should have more space. See, this space I don't want to remove. That's the problem. Now your O and X can be removed if you want. That is not required. OX is removed. See. So this is how much? 50.8. If this is 50.8, from here to here will be, this is calculated value, not given, calculated. This is 170 minus 50.8. 119.2. 119.2. What to do? This distance is 119.2 calculated value. Over. Now the intersection is centroid G, and this is our x-axis axis, horizontal axis passing through centroid of the entire area, capital XX. This is our YY, capital YY. See, extend further here. If space is not there, extend here. YY. Okay, write it clearly here. This is G. Okay, that's where I write it here. I want to tell something there, I forgot now. Something I wanted to tell. Suddenly I forgot what I wanted to tell. Okay, leave it. No problem. I remember later. What I wanted to tell, I forgot. Okay, 1 minute. Anyway, I had to go to moment of inertia now. So I will take it. I already told you about the sketch here. Okay, now calculation of moment of inertia about xx and yy. See, next time all I won't write this much. That is about horizontal and vertical centroidal axis for entire area. That is I about xx and yy, the most important part. Class, very, 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 very important. You write, and this will not do once again now. See, somebody will tell, sir, why use parallax? See, I will tell something now. This I will not tell again. Sir, why we want parallax theorem? Because we want I about centroidal axis. Formula is there. No. The given lamina is divided into two parts. Two rectangles are there. Our moment of inertia expression is about the centroidal axis for the component. See, you know what is moment of inertia about? Axis passing through G1 and G2. See, for the entire lamina, this G is not centroid of any part. See, for part 1, centroid is here. For part 2, centroid is here. But we want, this is G is centroid for entire area. So therefore, as when you consider G1 and G2, XX and YY lies outside. So even though XX and YY are the centroidal axis, now for parallax theorem, it will become any axis. Because see, here it is a green color. IG means parallax theorem will first start from I about its own centroidal axis. See, part 1, own centroid here, own centroid here. So this I will not tell again and again, first and last time. By parallax, we will use parallax theorem. By parallax theorem, I about any axis. See, last time I am telling, in future I won't explain. IG, moment of inertia of the area considered about an axis passing through centroid G of that area. I forgot to write one thing. And also one more thing, forgotten. Okay, last time. Passing through centroid area, centroid G. See, the statement I put here now. Centroid, okay, this way, okay. Passing through centroid G of that area and parallel to axis about which this all explained, which moment of inertia is required. So systematically I told. IG means moment of inertia of the part considered about an axis passing through its own centroid. But that axis should be parallel to required axis. If you want I about XX, that own centroidal axis should be parallel to XX. If you want later I about, you write here, when you want I about XX, for both the component, you should consider centroidal axis parallel to XX. And when you want I about YY, you should consider centroidal axis parallel to YY. A, area considered. H is perpendicular distance from centroid G of the centroid from, don't write G, you write here, perpendicular distance from centroid of the area considered, that is small g, to the axis about which moment of inertia is required. This all you write correctly. In future, these all I will not tell. Over. That's all. Last time over. Now, there's a limit for everything. I will tell if difficulty is there in future, go back to old classes and especially to the class of the master example. See, I told master question. Go through master question again and again and again and again till you get perfection. Again I told you, want to study from me, learn from me, you should listen to what all I tell and also carry out it. What are instruction, or sometime I will tell order. If it is online class, I will tell instructions or information for you. Offline class, I will tell it is order, remember. Here I can't do that way. Okay. Therefore, unless you are serious and dedicated, my class is not suitable for you. This is told repeatedly many times. Okay, now I will write expression. Okay, we will start now. These numbers are not for you. It is for this is not required for you. Leave it. It is for checking purpose. Don't worry about it. I checked the answer some other way. So don't worry about it. Start. Now everything is told. I explained very thoroughly. Start. Actually already over. See correctly. I about XX. First, come to everything this question I will tell once again. See, I wrote which are component part green color, which is important part red color. Next time this way coloring and this way writing every time IGAH is not possible. Next time I won't tell that. Start. First come to part number 1. Its centroid is here. Put the finger here. Then put the tip of the pen. Through centroid G1, you consider an axis parallel to required axis, that is x-axis. See, light line. First write I about this axis. I about this axis for this rectangle is 16 into 150 cube divided by 12. This is told many times for rectangle, parallel side into perpendicular, cube by 12, Ig plus area. 16 into 150 is the area into from centroid of the component, see G1, to the required axis, see, perpendicular, that is see here. Instead of writing there, I can write this way distance, see, it is this distance square, light line mark here. You can make a light line and write here, this is the distance to be considered H for part number 1 when you find I about XX. This distance is 119.2, see, minus from here to here. This is 150. When this is 150, centroid is at 150 by 275 here. So 119.2 minus 150 by 2 whole square, Ig plus A square. Explained many times and also will come in future. So study thoroughly. Start. Plus come to figure number 2. First come, it's centroid here. Axis passing to centroid and parallel to x-axis. See, light line, this axis. This rectangle is 130 by 20. About this axis, I is parallel side 130 into 20 cube by 12, Ig, plus area. Area I don't have to explain, into perpendicular distance from centroid of the component to required axis. See, from here to here, this distance square. That is from 50.8 subtract half of 20. Very crystal clear. Whole square. You get IXX. I wrote full number today for some reason. This is the IXX you got in a millimeter power 4. Start. I about YY. Now do one thing. Remove this one. All use pencil. See, use pencil to understand. Remove it. Start. I about YY. YY. Now first come to part 1. Axis passing to centroid parallel to YY. It is, see, somewhere here. This is centroid of the axis for that one. For that parallel side is 150. 150 into 16 cube by 12 Ig plus area. Okay, area into from centroid of the component to YY, this distance square. That distance is, see here, this distance is 37.64. This full distance subtract half of 16. That distance to be squared. Ig plus A into H square. Okay. Inside bracket is H, square is outside. Then come to this one. Axis passing to centroid parallel to YY. See, it is here. Parallel side is 20. 20 into 130 cube divided by 12 plus area into, see, this distance square. That distance you can do in 2 different ways. If you look this way, it is 92.36 is this distance. This is 130. Centroid is at half of 130. So 92.36 minus 130 by 2 whole square is H. Or one alternative, see, from centroid to this extreme edge, see, this is 130. So this centroid to here, this is 150 by 2, this also 150 by 2. See, from G2 to here is 150 by 2. From 150 by 2, subtract 37.64 or 150 by 1, not 150, 130. Oh, okay. Forgot. It is not 130. Not 150 was somewhere there. Sorry. See, this distance square. I told Ig is what? 20 into 130 cube by 12 plus area 20 into 130. I got confused about 130, 150. Into this distance square is, see, this is 92.36 minus 130 by 2. First one. Or this is 130 by 2, this also 130 by 2, midpoint. From from 92.36, subtract 130 by 2, or from 130 by 2, subtract 37.64 whole square. Both are okay. You get I about YY. So this will complete moment of inertia about centroidal axis. Okay, now some extra information. This I am removing now. Okay, I will remove this one now. Sufficient. Okay. I write something else now. Oh, I forgot the number. I should have noted down the number. 1 minute. I think a number is stored in the calculator. For future calculation, I think I stored it. 1 minute. Shift store A. Yes, 13.6 IXX. This is IXX equal to 13.603 667. How many sixes? 4, 6, 6, 6, 7. 10 to the power 6 millimeter power 4 is your IXX. And this is your IYY. Okay, now I will tell you something else now. Okay, over. Moment of inertia over. Now make a note. I will see this. I will not tell again and again. See, in the question right there, in question, I asked you find moment of inertia about all these axes, and also radius of gyration about all axes. A question right here. We are asked to find radius of gyration. That is, our symbol is R. About all axes considered. All axes considered in the question. Therefore, we know that we have in general, see, red color now, radius of gyration about any axis, that is R, equal to root of I divided by A. Okay, this one you write. Okay, this I can remove because I got the calculator answer is there. Okay, I can remove this one. I devote A, where I is moment of inertia about that axis, and A is cross-sectional area of entire cross-section. Okay, now this all you write here. Then I am rubbing now. You should write all these things systematically. Then only it will be clear. Okay. This is not required. The XX I can see the calculator. It is there in the calculator. Right. Then therefore, radius of gyration about XX, that is horizontal centroidal axis, that is called RXX, equal to square root of IXX divided by area, entire area, and right here, radius of gyration about YY axis, that is centroidal vertical axis, that is RYY equal to square root of IYY divided by area, entire area. Now write here. Entire area, area of entire section, total area equal to 150 into 16 plus 130 by 20. That is equal to, I think, 5,000. It is round number. It should be round number. Otherwise, centroid will cannot come that way. 150 into 16 plus 130 into 20 is, yes, 5,000. It is 5,000 mm square. Right here. Therefore, R about XX, once again not required. If you want to write radius of gyration about XX equal to square root of whatever is the IXX. IXX we got how much? Shift tore A equal to 13 point, that red color answer, 603 464 6667 10 to the power 6 divided by 13.60346, okay, divided by 5,000. That will give you equal to answer. Okay. Shift tore A 13 point into 110 to the power 6 divided by 5,000. Root answer 52.160. This time checking is not there. 160.26 millimeter. 585 millimeter. See, moment of inertia is in millimeter power 4. Area is in millimeter square. I told you, millimeter power 4 by millimeter square is millimeter square, root is millimeter, or radius. It is a linear quantity. Okay, and R about YY equal to square root of IYY is 7.76 76 186 67 10 to the power 6 divided by total area is 5,000 equal to shift tore B. It is there into 1 expansion 6 into 1 expansion 6. So much divided by 5,000. Root answer 39 point YY lesser, yes, correct, 39.4147 6542 millimeter. Now make a note, important note. I won't tell. Note. Last time I will tell. So in any question in future, if moment of inertia is not required, suppose the question is to find radius of gyration, even then first you have to find moment of inertia. Find moment of inertia, then find radius of gyration. Okay. Okay, then lastly, one more information. Information for you. Question not asked. See, this I will tell you for every question now onwards. One more information. Suppose in question they ask polar moment of inertia or polar moment of inertia passing to centroid. Polar moment of inertia again about centroid, not about centroid. Polar moment of inertia with respect to centroid. That is moment of inertia of entire area about an axis passing to centroid, passing through centroid G and perpendicular to plane of the area. Plane of area. That is IP. IP, or you can tell IZZ. That means here XX, YY, see ZZ. I cannot show it here. If you want, right line mark here. See? XX, YY, see? Z. Then IP, IZ equal to I about XX plus I about YY. Right here. By perpendicular axis theorem. Axis theorem. Therefore, in any question, if they ask you polar moment of inertia with respect to any point, then find moment of inertia once about horizontal axis, once about vertical axis, add those two and get the answer. So equal to IXX is forgotten, it is in the calculator. Okay, IXX is how much? Shift store A. 13.603 46667 10 to the power 6. This is your IXX plus other one is 7.7676186667 10 to the power 6. Answer will be shift store B. Shift store B is how much? Into 1 expansion 6 plus shift store A. 21.371 08533 10 to the power 6 millimeter power 4. Extra information. Okay. This is also over. Okay, now I am closing this class. I told already in the beginning, before I started the class, I made an announcement. See there, that this is going to be part 1 because part 1 is the most important. So part 2 is academic purpose or any competitive examination. See about BC, AB, it will never come in structural engineering. So what is required most important for structural engineering we covered. Even exam point of view also 99% questions will be on centroidal axis. Very rarely they will ask find I about this axis, find I about this, not here, here they will ask I about this axis. Or usually centroidal axis are the most critical. Okay, now go through the entire class, correctly get the grip. Next class in part 2 of this what question? Master question. I will finish everything. All this I will finish. This I will not remove. Okay, over. Thanks. We will meet in the next class.